So let's go ahead and talk about explanation of light creation. You may not necessarily feel this way, but I think this is one of the coolest parts of chemistry. I really enjoy this. Yeah, just the idea. Basically, we're talking today about how light is created, where light comes from, okay, which is cool, I think. So this is letter B on your notes, okay? And we've talked about this a little bit before, okay, but we're going to make some connections today. So electrons are found in energy levels around the nucleus of the atom, okay? This is kind of the Bohr model of the atom. Again, we're going to talk a little bit about the quantum model, but we're going to, anytime we draw the atom, it's got to be the Bohr model, because the quantum model is just a lot more complicated, okay? But there's your Bohr model, right? So the electrons can be found in energy levels around the nucleus, okay? And remember, they can only be found in those energy levels. They can't be found anywhere in between the energy levels, just like climbing up the rungs of a ladder, okay? This is related to Niels Bohr's model. I guess that's all I need to say about that. So the energy level where the electron starts from is called its ground state, okay? So, well, we're going to look at hydrogen in just a second, so, what's that? Yeah, this is already filled in, okay? So the ground state, right here, that's where the electron usually is, okay? That's where it exists under normal circumstances, all right? So, for example, with a hydrogen atom, it has one electron in its ground state, okay? Now, listen up. So you've got one electron in the ground state of hydrogen. If you start talking about helium, helium's got two electrons, so it has two electrons in its ground state, okay, right there in the first energy level. You get something like lithium, it has two electrons in that first ground state, and then it has one electron up here. And we're going to learn all of this later. I'm just kind of showing it to you for now, okay? So where the electrons normally are, under normal circumstances, that's called its ground state, okay? Oh, here's a better picture. So there's an electron in a hydrogen atom, okay? It only has one electron, and it's in this first energy level, okay? Is there anything to fill in? Nope, nothing to fill in there, okay? Now, if we change the energy, we can actually make those electrons jump up to higher energy levels. Do I need to shut this? I feel like we're distracted. Okay. So if we add energy to this atom, the electrons will jump up to a higher energy level. Okay? Now, what are some ways that we could add energy to an atom? You could heat it up, right? You could look at it. You could hit it with light, right? That actually makes the electrons jump. No, okay. So when you hit it with visible light, the electrons don't, unless you hit it with UV light or light that's very close to the UV side of the spectrum, the electrons typically don't jump, okay? If you hit it with X-rays or gamma rays, they're definitely going to jump, UV rays. If you hit it with microwaves and stuff like that, those wavelengths are too low energy to actually make the electrons jump up to the next energy level. So that has to be certain types of light, okay? But if you hit it with light, the right type of light, then it will jump, okay? What else can you do maybe to an electron to add some energy to it? Any other ideas? There's one other one we're going to do today, and it's on letter B, electricity, right? Okay, so we're going to actually play with all of those today. It says excited. Sorry. Oops, that was a little off. So you give an electron energy, it gets excited. Just like a little kid who's had too much sugar, right? And when it gets excited, it jumps up to a higher energy level. My son gets really excited when he has sugar, like way too excited. Like for his second birthday, he fell down and almost broke a tooth after he ate cake, because he was running around like a crazy person. It really affects him for some reason. I don't know. All right. So what happens then after the electron gets excited? Eventually, the excitement wears off. Okay. I had a student last year in one of my honors classes. She was describing this on the test, the whole idea of why electrons give off light, and her description was, I think she had just gone through something with a relationship, because her description was, she said, when you add energy to the electrons, they get excited and they jump up to a higher energy level, but as with all relationships, eventually the excitement wears off, and it falls down to a lower energy level. I was like, there's something personal going on here.
Is that right?
It's right, yeah. I mean, well, maybe not the as with all relationships. I guess that's sort of right, too, honestly. But anyway, point is, the electrons will eventually, they will lose that energy by dropping back down to their ground state. So they can't stay excited for that long, okay, unless you just keep adding energy and you keep adding energy, okay? But eventually those electrons will fall back down. When they do, they give off light, okay? That says light. Is that one of your blanks you have to fill in? Yep. So the electrons, when they fall back down to their lower energy level, they give off energy in the form of light. And guess what? That's where all light comes from. Kind of crazy, huh? There are electrons and atoms doing this in the sun. You didn't let me finish. There are atoms with electrons that are doing this in the sun right now that are creating the light that travels to us from the sun, and that's where our light comes from. Kind of interesting, huh? I think it's kind of interesting. So there you go. Okay? As the electron drops back down to a lower energy level, it gives off light. This one's giving off yellow light, apparently. Okay, now depending on the size of the fall the electron makes, that's going to determine the wavelength of light that's given off. Okay? They may fall down in specific steps. Each step has a different energy, so that determines the light that's given off by that particular electron when it falls. Okay? This is showing the different series with hydrogen. So Bohr was the one who came up with this whole idea. He's like, hey, I can explain where light comes from, and that was pretty revolutionary. But he could only do it with a hydrogen atom. So he used hydrogen. This is the energy levels that an electron can jump to in hydrogen. Now, normally in hydrogen, the electron's right here, okay? But these different series, he named them, and these different series basically tell you what sort of light is going to be given off depending on the size of the drops. So right here, anytime that something drops from a higher energy level down to the second energy level in hydrogen, visible light is given off, okay? So notice, you should see 4 different colors from hydrogen because there are 4 possible drops of the electrons to the second energy level. Does everybody see that? It could go from the 7th energy level down to the second, 6th to second, 5th to second. Nope, I counted that wrong. Sorry, that's 6th to second, 5 to the second, 4 to the second, and 3rd to the second. Okay, so you should see 4 lines in the visible spectrum related to those drops. Okay, we're going to look at hydrogen in a spectroscope in a second. You should be able to see 4 lines of color on it. Okay, the further they fall, the more energy gets released, and the higher the frequency. Remember, frequency and energy are directly related to one another. We learned that yesterday, right? So if something falls a long way, go back to this for a second, okay? If something falls from the 6th energy level down to the 2nd energy level, we would expect that to be a higher energy light, okay? Does anybody know what the highest energy visible light is? Did you guys ever learn Roygbiv? Yeah? Okay. So some of you don't know what I'm talking about right now, some of you do. Roygbiv, okay? Red, orange, yellow, green, blue, indigo, violet. Okay? Violet is the color that corresponds to the highest energy in the visible spectrum, okay? So the wavelength of light that produces violet, that's the shortest wavelength, the highest energy, okay? Red is actually the lowest energy visible light. So you go a little bit lower than red, you get to infrared, below red, okay? You go a little bit higher than violet, you get ultraviolet, more than violet. See how that works? Okay? So this right here, this drop from the 6th energy level down to the 2nd, probably makes violet light. Does that make sense? Because it's a big drop, gives off a high amount of energy, so that's going to correspond to a high frequency light. Okay?
What if it goes all the way down to 1?
If it falls down to 1, then you're going to get something that's probably not in the visible range. These right here correspond to ultraviolet radiation. So you won't be able to see these. Okay? It gives off, what's that? Yeah, that's how black lights work. Okay? It's giving off UV light. Okay? So basically this is dropping further, so it has more energy. So, and then these right here, these would correspond to infrared, right? Because they're only dropping down to the 3rd energy level, so not as far of a drop, not as much energy, so that's where you get your infrared from. Okay? Okay. So again, this is a very simplified explanation, and Bohr was only able to get it to work for hydrogen. You need the quantum model to explain everything else. But it works well for hydrogen. The orbitals have different energies inside the energy levels, which we'll talk about later once we get to the quantum model, okay? But the electrons can move around inside each of these energy levels, okay? So again, just be aware, this is a little simpler than it actually is, but it gives you kind of a good idea of how these drops work and how they correspond to colors, okay? Now, what brought all of this about was some observations that scientists were making about what happened to certain gases when you pass them through light, okay? So what we're going to do now is spend the rest of the hour basically playing with some fun stuff, fire and electricity and all of that. So I think you guys are going to have fun with the rest of the day. You can pack up your notes and everything, and we'll just talk about how all the rest of this stuff works.